I'd like to welcome everyone today to our webinar. Today is February 25th, 2016, and welcome from the Woodland Stewardship Education Program of the University of Maryland Extension. My name is Andrew Kling. We're here to talk about commercial wood energy grants. Do you have a viable project? Today we're going to be joined by Jonathan Kays, my colleague from the University of Maryland Extension, Paul Lewandowski from AFS Energy Systems, Dan Ryder from the Maryland Department of Natural Resources, and Chris Clark from the Maryland Energy Association. We're going to run for about an hour, but before we get started, we have a little bit of housekeeping to go over. Our webinars are given on a periodic basis. We try to do them quarterly. 3 or 4, 5 or 6 a year, depending on how ambitious we're feeling. This is our second one this year, and like all of our webinars, this one is being recorded, so if you discover there's someone else you think might benefit from hearing this, it will be recorded and will be available on our YouTube channel probably next week. Go to youtube.com/c/UMDFSE and you'll find it there, and you can send the link to anyone you wish. We also have a website at extension.umd.edu/woodland. There you'll find all sorts of information about our Branching Out newsletter, which is also a quarterly affair. There's also a great deal of information about how to manage your woodland property, how to deal with invasive species, how to deal with timber tax issues. There's a great deal of information there. And we're also on Facebook at UMDWSE. That one takes a little bit of a larger view of woodlands in general, not just Maryland, but national and global woodland issues as well. So as I said, we run about an hour today, and the first person we'll be having is Jonathan Kays from the University of Maryland Extension. And during these presentations, we should have time for some questions. If there's one that comes to mind, go ahead and type it in the chat box down in the lower left-hand corner. If we don't get to your question, we'll get to you later on. Just email it back to me at akling1@umd.edu, and we'll put you in touch with the person who has all the information, or we'll send the information directly to you. So with that being said, I'd like to thank you for joining us today, and we'll get ready to bring Jonathan in, and he'll give you a little bit of an introduction into the topic. And Jonathan, take it away.
Welcome. My name is Jonathan Kays. I'm a Natural Resource Extension Specialist with the University of Maryland, but I've also served as the informal chair of the Maryland Wood Energy Coalition. And the purpose of this webinar is to kind of provide some information about the Maryland Energy Administration's commercial wood grant program that's available and can be a great incentive to implementing a biomass or wood energy project for your facility. My goal here is to give you a little bit of background on the Maryland Wood Energy Coalition and what that is about and how this worked into this grant program that's available. But the Wood Energy Coalition was organized in 2010 to kind of advance wood energy into state policy. And since no one organization had the capacity to do that, a number of agencies, nonprofits, and biomass-based industries that you see listed here kind of got together. Some of these were at the outset, some came along in the following years to kind of decide what the issues were and how to advance wood energy in the state. And in fact, we were kind of behind other states in the use of wood biomass, such as wood chips, especially as a commercial fuel to fuel facilities. So there was a lot of meetings that took place, and the Wood Energy Coalition kind of came up with this mission to advance the responsible use of Maryland's vast supply of woody biomass for clean, affordable thermal energy production. And it was felt this was best achieved through the use of small to medium-sized commercial and institutional applications for government buildings, for schools, for businesses, and in addition to the commercial applications, as well as to promote and develop more residential thermal applications. And so that was the mission of the groups that got together, and like I said, it was wide-ranging groups of agencies and nonprofits and the biomass-based industries that you see here. They kind of worked together towards this goal. And one of the first things that was done was to kind of come up with this prospectus for advancing biomass thermal energy in Maryland, and this is available on the website you see there, extension.umd.edu. And when you go to that webpage, you'll see a tab for wood energy, and there are separate sections for the commercial as well as for the residential wood energy information that's available, as well as information on this grant program that you'll hear about as well. And this really set the stage for policy and defining what the position was or the situation was in the state of Maryland and what could be done to advance this technology in the commercial sector as well as the residential sector. Where is Maryland now? After, especially with regard to the use of commercial biomass right now, well, Maryland really has, at this point, one wood energy facility that uses wood chips, and that's a 4 megawatt Eastern Correctional Institution on the Eastern Shore. And they've used, they've cut their fuel costs. This was done in the early 80s, in the mid 80s when this facility was installed. They've saved a lot of dollars in fuel costs. Since that time, and as a result of the Wood Energy Coalition, new regulations have been passed in Maryland that allow more expansive use of woody biomass as a commercial fuel in facilities. And it's important to mention that Maryland is behind other states in this application. And it's also important to note, and when Paul Lewandowski comes on from AFS Energy Systems, he'll probably make the point, and you'll see from his presentation, this is technology that's readily available. It's off the shelf. It's being used in many, many applications throughout the country. This is not experimental, and it's extremely clean burning technology and computer controlled. So we're in a different age from the old smoky stove and things like that. The vision here for Maryland is to kind of create a whole new industry because with jobs, better management, wealth retention, energy independence, and energy security, it's important to note that every time you pay an energy bill for fossil fuels and other things, it goes to some out-of-state corporation or entity. Wood has to be sourced locally, usually within 50 miles or so. And that means that money, those energy dollars are spent in the community. And it also provides energy independence when things change. Although fossil fuel prices are low now, will that be the case in the future? And who can say? So there's this idea of creating a whole new industry around the use of woody biomass. And from a consumer's perspective, this fuel is extremely cheap compared to fossil fuels. It's very predictable. And Dan Ryder will talk about the fact that wood is a sustainable resource. There is a lot of wood out there in the state of Maryland that's accessible and sustainable. And again, the fuel dollars stay in those local communities. So that's the promise of wood as the Wood Energy Coalition sees it. And the coalition over the years since 2010 has taken on a number of activities to educate and engage policymakers and regulators, and through a number of statewide energy conferences that you see mentioned there. We've also done a number of tours of wood energy facilities in Pennsylvania, where they've applied this technology in many schools and hospitals and greenhouses and other places extremely successfully. Maryland's also been involved through the University of Maryland Extension with a number of residential heating workshops to encourage the use of wood at the residential level. And of course, we've done some research on outdoor wood boilers, and we've done some other programs. And the whole purpose of this, and I think we've been successful, is to make people, policymakers and others, aware that this is a clean technology. This is clean, renewable energy. And again, we've done a number of tours at a number of facilities up in Pennsylvania. And the purpose of the Commercial Wood Grant Program is to really incentivize and create the opportunity for new projects in Maryland by funding feasibility studies. The coalition over the years had 4 priorities, and most all of these have been addressed. First was to update the Maryland air emission regulations. So there are set emissions, for urban and more rural areas. It's known what has to be done, and the technology is available there to do it. There's been an effort to create a thermal renewable energy credit, which has not really been that successful at this point. One thing that was done was to establish a residential wood grant program. In the state of Maryland now, if you install a clean burning wood or pellet stove, the Maryland Energy Administration will pay $500 towards a wood stove and $700 towards a pellet stove. And in 2015 alone, over 1,000 grants have been provided. And the last thing is for public facilities and agencies to lead the way. And really that's what the Commercial Wood Energy Grant Program is about, taking the initiative to make that happen and lead the way by providing that incentive. And at the outset of this, really, and the bottom line of this is that Maryland, I think, is about the 5th largest user of fossil fuels in the country on a statewide basis. You can see from this graph here about $90 million, I believe it is, on commercial use. And if only 20% of that fossil fuel use could be replaced by the use of wood chips, for example, or even wood pellets for commercial applications in thermal heat and things like that, that's a lot of money that would stay in the state and in local communities. And that's a very important aspect of using locally sourced renewable wood resources. So that's kind of what I have to say, except for the fact that when you look around Maryland, there are a lot of opportunities for projects in Maryland with the university, public schools, military bases, government districts, poultry houses, office and retail complexes, and prisons, anywhere where you need a lot of hot water or steam, a lot of thermal heat. And again, the purpose of this webinar is to kind of, through this, make people aware of this grant program, to submit some project ideas by the March 30th deadline. So with that, I'm going to sign off and just tell you that, encourage you to go to this website you see here, extension.umd.edu/woodland, and look at the Wood Energy tab and see the kind of some short videos and other resources that are available for your use. And I think with that, we're going to move on to Paul Lewandowski with AFS Energy Systems, who's kind of give you a little background on the technology and understand how this works and what are some of the questions that perhaps you should be asking. So with that, I'll sign off.
All right, thank you, Andrew. Thank you, Jonathan.
Okay,
I
Paul,
do want to plug that prospectus, Maryland Wood Energy Prospectus. That is a very well-written document and provides a lot of good background information on some of the things that I'm going to talk about specifically in Maryland. So first, thank you for the opportunity of spending this time with you and attending this webinar. Hopefully this will be the first of many opportunities for us all to learn more about the benefits of renewable thermal energy produced with biomass. We're going to take a look at some guidelines, how we evaluate and perform an analysis of whether or not a facility is a good candidate for the application. So what are the necessary components for a successful project application? A little bit of background. As Jonathan said, I've been with AFS Energy Systems for about 6 years. I was hired to develop projects. I'm a previous general contractor, and I also ran the plumbing, heating, and steam fitting department for a major hospital in Lancaster, Pennsylvania for 8 years. So I have hands-on steam and mechanical experience. So I know my way around the boiler room a little bit, and that can get me into trouble sometimes. So what is biomass? All organic material that can be converted into energy is called biomass energy. So that includes a number of different things. We're particularly going to speak more about the woody biomass, wood chips and other cellulosic material. But it can come from agricultural crops and forest products, industry waste. And this is where AFS Energy Systems really started 30 years ago. We supported many forest products companies with equipment that would convert their wood waste into steam energy, which they would use to dry their lumber. So they were getting free basic energy. A lot of them used to run fuel oil or propane to do that, and they started to realize that they had a resource right in front of them that they could use to generate their own thermal energy. So why biomass? Biomass is clean, renewable energy. It's a resource, as I said, that and Dan's going to speak to this, when done in a sustainable manner, is very clean, and it improves our environment and reduces the use of foreign fuel. And this is really the key part of it. As Jonathan mentioned, trying to keep those energy dollars in Maryland, and this is one way to do it. even just recently, the federal government has recognized biomass as part of their strategy for reducing their fossil fuel use, and along with that, greenhouse gas emissions reductions. Why biomass? Unlike the combustion of fossil fuels, the CO2 that's released by biomass is balanced by the carbon dioxide captured in the recent growth of the biomass. And this next slide really sort of demonstrates that idea. And statistics show us that for every tree that's harvested for energy purposes, 3 to 5 are planted, and that recent growth offsets the de minimis CO2 emissions that result. Another reason is it reduces costs. And this is an up and down thing. Costs go up and down. But if you look at history over the last 20 years, biomass, wood chips, resources have stayed relatively flat with just minor increases in cost over 20 years. Whereas when you look at all the other fossil fuels, there's a lot of volatility, a lot of ups and downs, and mostly with a trend up. So there was a time when we were replacing many, many natural gas boilers when it was $14 a therm. Well, you know, natural gas is down there very low right now. So, you know, but in the long term, and that's the way these have to be looked at, they have to be looked at as a long-term investment. So here's just some examples of when wood is purchased at $40 a ton. This would be the cost per million BTU, and that's how we analyze the efficiency of and the cost of the fuel. The wood chips would be about $6.50 per million BTU at $40 a ton. Number 2 oil would be about $21.50 at I think $3 a gallon that was at that point, and propane was over $2.50 a gallon, which it's lower now, but it would have been the highest at that point. So if we were going to target the most likely candidates right now for biomass systems, we would target those utilizing oil and propane, even at the lower costs that they are right now. The different types of fuel, obviously everybody knows pellets, pretty much have seen those, sawmill chips, roadside trimmings, yard waste, systems that we have engineered handle a variety of biomass fuel. A new emphasis for us right now, a lot of our customers have been asking us for bark, to burn bark. Now, you know, there's a little bit of problem with that. You have to engineer it in the system because bark produces more ash and it's harder on the equipment. But we actually have developed a system that burns nothing but bark for the wood products industry that's been asking for that. So where can you get the fuel? Well, most systems, folks get them from sawmills, tree trimming companies. There are even some fuel brokers, but most of the chips come from wood products companies that are actively involved in producing the chips, probably for years and years, produced them for the paper mill industry, which has pretty much dried up everywhere but China. And so there's a lot of biomass that used to be used in the paper mills all across the country, which is readily available now. And there's actually more trees and more biomass available now than there was 50 years ago. So there's no, and Dan will get into this a lot more, I'm sure, there's no problem with resourcing biomass for systems. Okay, now we get into the systems themselves. What does a biomass system look like? Don't they have to be ugly? No, they don't have to be ugly. This is a boiler room, believe it or not. This is Bennington College in Bennington, Vermont, and they were so proud of their biomass systems they installed big windows so that the students could look in and see renewable energy in action. And Bennington, they basically paid for their system in less than 3 heating seasons. So, and they made it a very part of their attractive campus. This is Longwood University's boiler room. Longwood University in Farmville, Virginia. Very federal-looking campus. They incorporated a very nice building. That tall section actually houses a big silo, and that's where the wood chips are stored. And those big windows, again, they wanted the students to see the biomass system installed. They have 2 biomass boilers now, and they're looking at a 3rd one in that last set of windows on the left-hand side. They're looking at one that will produce power. This is a little bit more of what you would expect to see with a more utilitarian look for what we call the fuel bunker. A pre-engineered metal building system is typically what's done there. In that inside is the concrete walls. Basically, the fuel delivery trucks come up to that bunker. They back up with a walking floor trailer, and it walks the fuel right into the bunker. And in the bottom of the bunker, we have what's called a wedge floor, and those metal plates that are shaped like a shark fin basically reciprocate back and forth and massage that pile down, and then on the stroke toward the back wall, pull some fuel onto the conveying system. And that's the opposite side of that wall where the hydraulic rams pull that fuel onto a conveying system. A good idea is also to install a magnet to remove any metal in the fuel. It's amazing how many nails and chunks of metal end up in wood chips if you don't. And so that's something that we highly recommend doing. The other part is this, for the material handling, this is what keeps the properly sized fuel only getting into the system. And once the fuel has been screened for metal, it is now screened for proper size that will easily flow through the remainder of the fuel delivery process. With a vibrating or shaker table, sometimes called, the overs are eliminated from entering the system, and only properly sized fuel enters the next piece of equipment. So in this particular slide, on the far left, you see the properly sized fuel going up a screw conveyor, and on the very end, you see another rubber belt conveyor where the overs would end up going. And in this particular case, this was an application where they wanted it completely automatic. So the overs, rather than going into a wheelbarrow, basically went up a conveyor, get a full load, and then it would grind it and put it right back into the pile, so they didn't have to touch it. And today, most healthcare institutions, hospitals, and other institutions don't want to handle it, so we have completely 100% automatic systems that are available. The next piece of equipment, once that good, properly sized fuel comes into the top of that blue conveyor, drops into what we call the metering bin. And you see a high and low control there and a little piece of plexiglass in the middle, so you can see what level of fuel is in that. And that basically acts as sort of a chambering of a gun. And it chambers the next load of fuel. And then at the very bottom of that, you see a black fan there. That pneumatically then delivers, with air pressure, that fuel into the furnace. The next slide here shows a plan, a drawing, floor plan for a system, total system, with 2 storage silos outside the bunker. You see the scrapes at the top left-hand corner, and then you see conveyors that convey to a bucket elevator that load 2 silos. And then the rest of that drawing on the right-hand side shows the 2 wood-fired boilers that would handle this system. This is a large system that was designed for New England, and they wanted a lot of extra wood storage because sometimes trucks have a hard time getting around in the wintertime up in northern Maine. And here's just what the silos look like. They come in varying shapes and sizes. They're nothing out of the ordinary, but they provide a solution when there's a tight site or there's more storage needed on a smaller footprint. The next part of the system that we'll talk about is what we call the stoker system, and the stoker is the method of how the wood fuel, the chips, the dust, the sawdust, whatever fuel pellets, how they end up in the furnace and become part of the system. On the left-hand side, you see what we call, that's the pneumatic. So you remember the metering bin and the fan. When that fan directs compressed air to this pipe, pushes the fuel into that pipe there, and it goes right into the center of the furnace. Directly above that, you see valves. Those are all overfire air ports. So all through the top of that furnace, there's air being strategically directed at that combustion at proper times to get the right O2, and there are O2 sensors and thermocouples there to measure the proper amount, and so it can be adjusted automatically to enhance the combustion, and that's the reason why these systems are very, very efficient. There's also underfire air. And on the right-hand side, we have more of a mechanical situation where you see the red metering bin. That's actually the metering bin and the stoker screw as one component. So they're combined. And they can either be an overfed or an underfed depending on the type of furnace. There are a number of different furnace styles, and they're dependent on basically the kind of fuel and the type of boiler that's being used. Some have a sloped retort without reciprocating grates, but we also have a number of systems that have reciprocating grates that move back and forth to move that inside the furnace, move that fuel from the beginning of combustion down to the very bottom in ash. So it's as Jonathan said earlier, they're not smoky wood stoves. These are very high-tech systems that just happen to use solid fuel instead of a liquid or gas fuel. And the boiler systems themselves, the boilers, there's a wide range of shapes and sizes. There's hot water, low pressure steam, high pressure steam, ranging in size from as small as 40 boiler horsepower up to 1,200 boiler horsepower, 450 psi steam, which is used to generate power, and are available for CHP systems. So the boiler on the left is a high pressure 450 psi boiler. You have a fire tube section and you have a water tube section, and you can also see those air valves down below the smaller boiler section, and then you see the much longer boiler section, and then even on the other end we can even add a superheater to these systems. So if you get into a really high CHP application, we can even put a superheater on them. And then on the right is a low pressure, and that's basically a standard sort of Burnham boiler, or that's added to our furnace system. We've actually purchased those. So we have flexibility. We're not tied into any one boiler company, so that we have a wide array of opportunities to select a good boiler for each specific application. And this is just some more examples of some large systems. This was a furniture plant, I believe, in Canada. And we have some case studies that we'll share at the end that show some of these as well. This is another firebox and boiler high pressure application. So there's a lot of opportunity for finding just the right application for whatever situation. In this case, this is a wood products company in central Pennsylvania, owned actually by an Amishman. And if you look on the left-hand side toward the bottom corner, you'll see his straw hat there standing by the yellow pole. That's him watching us set major equipment on major equipment's set day. You have the furnace, you have the boiler being set on top of it. In the foreground, directly below that, you have the orange metering bin, and then you have the fly ash collectors on the left-hand side, which are the air pollution controls, and the flash tank, all inside the building before the building's built up. And that's the best way to do this. Now, when it's a renovation type situation, then possibly we're having to take the roof open and drop things in, or take a section of wall out and walk them in with a tow motor. It just depends, but this is absolutely the best way to do it if you have opportunity to build the building first. Just put the walls up and drop the equipment in. The next slide, as I mentioned, the fly ash collectors. They're the first line of defense for providing a clean stack, and basically they are just a tornado being introduced into the center of that system. There's tubes, and the particulates falls out the bottom, and the hot air goes out through the stack. And those are typically, we use those basically as a pre-filter now for more advanced and higher efficiency emission controls that are required to meet the new clean air standards. So bag houses are used for emission control. They tend to need more maintenance. So really what is being used most now, because costs have come down and the technology has been improved, and mainly the cost has come down, is now most systems above 10 million BTU under the new boiler MAC requirements will end up with an ESP. We'll still have a fly ash collector to take the larger particulate out first, and then the ESP as a secondary means. And there's no situation that can't be turned into a completely clean system with this equipment. There's none of the systems that we've installed have ever not passed a stack test as a result of using this equipment. So you can see there's a lot of things here that are probably that you haven't really seen before if you're not familiar with the technology today. The other thing that kind of blows my mind a little bit is, so I've been doing this for a long time, and I started a preventative maintenance program for the hospital. I was using 3x5 cards in a box to keep, before we had computer software to do it. Here's a really neat. We build all of our own control panels. They have a touch screen in them. We actually can modem into any one of our customers and monitor what's going on with their system, help them with any issues they might have, and help diagnose any problems from our office. So it's a really nice feature. These have variable frequency drives for every fan. So those fans that are supplying fuel are actually on a variable frequency drive, and they're only running when they need to be, and they're only running as high as they need to be to perform within the parameters of the system. The other neat thing is we just finished a couple systems for the state of Vermont, and did the first control panel that ended up it's in their cloud-based system. So now we've kind of talked about the technology and what's available, and now we want to sort of look inwardly to application for my particular facility. If you have if you meet certain parameters here, we're going to kind of go down through a list, and we're going to do it pretty quickly. So here's the first one. Do you have a present system? Are you using fossil fuels? Do you have a central plant? A central plant is the most effective way of utilizing thermal energy rather than separate systems in each building. There's just the economies of scale. Size does matter. 50,000 square feet and above is kind of arbitrary, but if it's less than 50,000 square feet, it's going to be hard to make a system return on investment work without the more square footage, the better. Let's just put it that way. Do you have thermal loads throughout the year? Do you have steam, hot water, chill water? If there's a levelized load over the seasons, it's a much better, it's a much more favorable situation for an application of a system if there's more levelized load throughout the entire year. Hospitals have that. Hospitals are a really good application. They always use steam, and they use hot water and chill water in the summertime. We always throw a question in there that that a customer can't say no to. Of course I don't want to. Of course you do. You want to try and control the future impact of rising energy prices. Don't be fooled by where they are right now. This is a direct result of basically an oil cartel trying to drive a bunch of American companies out of business, basically declared war on us. And this is not going to last. Is your system older than 25 years old? You know, a good time to think about replacing your system with a biomass system is before it actually craps out on you, and you actually plan for it rather than wait for it to break down in the middle of the night sometime. Again, same kind of an idea. If you're planning to retrofit or upgrade, it's a great time to do it because you would be spending the money anyway. And now you can spend it on a more efficient, sustainable, renewable system than just another fossil fuel system. If it is important for you and your organization to reduce your impact on the environment, this is another reason to look at this. And do you operate at least 5,000 hours a year? That's basically a heat season for most of the folks that utilize biomass for heating. Some folks I've talked to, customers have done all the low-hanging fruit in their institution and still end up with high energy costs. So they're always looking for another way to do that, to lower their costs. And this is just an example. If you're paying 8 cents for electricity, $3 a gallon for fuel oil, and that's probably high right now. There's fuel oil out there for less than that, but this was generally where we were with pricing about a year and a half ago. Do you have realistic return on investment payback periods? Are you looking at realistic things? I've worked with some corporations that wanted a 1-year payback, and that's all they could do, and they did their lighting plan, and that's about all they could do with a 1-year payback. But if you have a 5 to 10 year payback is reasonable for you, a system can pay back within that time frame. Not all of them do. Some take a longer view. In some states, they can up to 20 years for public buildings because the systems last 30+ years. Here's an important one. Do you know if you have access to wood biomass resources? Probably the #1 question is, where do I get the fuel and how much does it cost? And Dan's going to speak to that in Maryland. I can just say that from our experience, $40 a ton for wood chips is probably the average cost around the country. Some are lower, some are higher. Up in New England, parts of New England, they're paying $55 for premium chips. But there are wood products companies everywhere, so there is availability. Would a combined heat and power system make sense for your operation? What are the benefits? The challenges right now for a CHP system are electric prices are low, but they're going up because the Clean Power Plan requires electric utilities to clean up their act, and a lot of the coal plants are going away, and in place of them, even the natural gas plants are going to be more expensive. So electric rates are going to be going up, and companies are trying to react to that and get ahead of the curve. And now is a good time to think about doing that if you've got a potential CHP application. And it's a good CHP application. The CHP is combined heat and power, which means you're going to generate power with the steam that you produce from your biomass boiler. You're going to use that power in your facility to defer your electric costs, and you're going to turn around and use that thermal energy in your process, in your plant, so that you're getting the benefits of both. and the systems are engineered to lead from the thermal side, so that whatever you're generating you use in your plant for the best efficiency. Are you in a deregulated market? That definitely helps. Hospitals have sometimes unscheduled power outages, and that helps with them. So if you answered yes to 5 or more of these, we offer a initial analysis of your situation with just 3 previous years of energy costs, on what you spent for fuel and how much, a little bit of existing boiler system information, and then we kind of tell you if the next level of analysis is a good idea for you. So that's how we sort of find out if there's a good situation. Here's a case study. This is a project that we just finished last year. This is a company in Jaffrey, New Hampshire, EMD Millipore. They're owned by Merck, the German pharmaceutical company, Merck Life Sciences. They replaced 14 oil-fired boilers on their campus with one AFS biomass boiler system, high-pressure steam, and it was capable of operating a CHP system with the turbine. So they had very aggressive greenhouse gas emission goals. According to their numbers, we have provided Merck with their 4th largest greenhouse gas emission reduction, responsible for 15% of their worldwide goals with this project. In their own numbers here, in their own little brochure that they hand out to people who visit their plant, and they handed this brochure out at their open house. These are their numbers. They're equal to removing 733 cars from the road, basically 3,500 metric tons of CO2 per year. And I don't think it's a coincidence that this project happened very shortly after New Hampshire legislature had enacted their thermal renewable energy credits. So they're ahead of the curve, and their legislation that they did to get those is really a good model for how to do it. The next slide, this is Bennington College, and I told you a little bit about Bennington. The college administration committed to lead by example in greenhouse gas emission reduction by replacing one of their fuel oil boilers. In less than 3 years, 3 heating seasons, they paid for it, and it serves 60 buildings on a 470-acre campus. Their facilities director, Todd Sicleri, reports that they rarely even run their backup fuel oil boilers anymore. So you have colleges, you have industry, and you have a hospital. This is Cooley Dickinson Hospital in Springfield, Massachusetts. The hospital was looking to upgrade their old material handling system. They had a biomass boiler in for quite a few years, and then they upgraded an old biomass system into a new one. And so we upgraded their material handling system and then put in a high-pressure boiler. They had a low-pressure boiler in before. They wanted to generate some power, so they put a micro turbine in, and they're generating power with their high-pressure system. Hospitals make a great CHP candidate because they always need steam and thermal energy. And that's pretty much all that I have, other than to say this is really a good thing to remember, that biomass applications, biomass to biopower, combined heat and power, is highly efficient, yet sometimes it's forgotten. 80 to 90% efficient CHCP systems are viable, and the results are a reduction of greenhouse gas emissions and fossil fuel dependence and a stronger local economy. And that is all my slides. So I'll turn it back, or we can entertain a question or two if we have time, or do we need to move on? I'll put back to Andrew.
Thanks, Paul. Yeah, let's keep moving. We'll bring Dan in, and Dan has some perspectives to share about supply and how this can this is actually feasible. So go ahead and take it away, Dan.
Okay, well, good morning, everybody. And My goal today is it's very simple. I just want to demonstrate that there's plenty of wood anywhere you go in Maryland. And please feel free to type in any questions that you may have. I'll keep an eye on the messaging box down in the lower left corner. So anytime any of us begin to have a conversation with somebody about converting their system over to wood fuel, or if they're building a new system and they're interested in wood systems, invariably there's always three questions that get asked very early in the process. How much wood's out there? Where is it going to come from? And does it ever run out? And you know, when you really start thinking about why these questions are being asked, what they're really asking is, okay, what's my fuel going to cost me tomorrow? So, you know, it's basic economics 101. It's all about supply and demand. And what I can show you is that as far as wood is concerned, it's not like fossil fuels that will one day be depleted. With wood, it's sustainable, it grows back. And currently in Maryland, we have a huge surplus of wood in Maryland. I won't go into many of these details on this slide. You could look at them later. And if you're really curious, just get a hold of me and I can just absolutely bury you in the details. But suffice it to say that we're growing about 2.5 more times wood than what we harvest or what dies naturally. This is across the state. And more importantly, do this test on your own. Trees literally grow, and your fuel will literally grow in your backyard. Go to any window in Maryland, look out of it, and you will see a tree. So where does the wood actually come from? It doesn't just show up by itself. Fortunately in Maryland, we're already producing the wood. We're just not currently using that wood as fuel. But there's no reason why we can't put this wood that we're already making for other purposes, put that into the fuel supply chain. And here's a list of the major categories, if you will, of suppliers. We're going to talk about each one real briefly right now. So the arborists. In Maryland, we call them tree experts, tree trimmers, whatever. But these are the guys that run around. Usually you find most of them in your more urban area, but they trim the trees that are problematic for whatever reason. They're the guys that cut them down, and they throw them in the back of the truck as fast as they can in whatever form they can get to it fast enough and haul it away somewhere. So their goal is to just simply get rid of the tree. They get paid to remove a tree. They don't get paid to deliver wood. So any system in the neighborhood that would stand itself up to consume wood as fuel, these guys would just absolutely love, and they'll beat down your door to become one of your suppliers. Natural wood waste recycling facilities. In Maryland, it's not legal to put wood in a well, I'll avoid getting too deep into those details, but in Maryland, the state encourages the recycling of natural wood. Let me put it that way. And so all throughout Maryland, we have special yards set up. They're privately owned mostly, and they receive wood, and they reduce that wood down to chip size, and most of them turn that wood into mulch and then turn around and sell that mulch to wholesale or retail markets. They collect a lot of wood. And right now the highest and best use for that wood is mulch. But when you talk with these people, they would love to diversify their market. And fuel is very attractive to them. You definitely have a captive audience if you engaged in a discussion about fuel with them. Loggers. Maryland's not really known as a timber state. When people think about timber as an industry, they're thinking about Maine and Mississippi and Oregon and places like that. But surprisingly, to many people, Maryland really is a timber state. We support active forest management in every county across Maryland, and every year we have active logging jobs, timber harvest in every county, including Montgomery, Prince George's, Howard, even our most rural even our most urban counties support to some extent a what we would call a traditional forestry regime. So anyhow, that said, we have a lot of loggers, we cut a lot of timber in Maryland, and just because of lack of markets, we leave behind about 50% of the tree. It's a lot of tons of wood that's not currently being put to use. And believe me, I talk with a lot of loggers that have been watching the fuel market emerge in other states, and they keep asking me, when are we going to get this in Maryland? There's a lot of strong interest from the logging community to diversify their markets through fuel. Sawmills, as Paul mentioned, sawmills are a prime source for supplying very, very high quality fuel. They already make it now. Most of our sawmills in Maryland that also have dry kilns are burning their own chips for fuel. These people are very smart. They know the savings that can be derived, and they've switched away from burning fossils and they're burning wood. And for them it's very easy, obviously, because they make their own fuel. What's not as well known is sawmills. The quality of the chip produced at a sawmill is very high, and the paper industry has a very strong interest in those high quality chips. So when you see a sawmill burning a chip, it's not without opportunity cost. So they're burning that chip, which is actually a product that they could be selling to the paper mill, but they continue to burn their wood as fuel instead of selling it as a product, because the savings that they derive from burning it as fuel outweighs the profits that they may generate by selling it to the paper mill. So if you happen to be within about 100 miles or so of a sawmill, you're going to be a good candidate for discussion with them about their wood chip as fuel. Aggregators. Paul referred to this class as fuel brokers, because that's what they are. In Maryland, we have several aggregators already, but they don't sell much in the way of fuel. All of the aggregators in Maryland actually, believe it or not, do sell a portion of their wood as fuel, but it's to out-of-state interests. So think about that. If these guys can collect the millions of tons of wood that they do, and they're turning around and selling that wood to out-of-state interests for fuel, then I think it's pretty obvious that they'd be very much interested in doing the same right here in Maryland, closer to home. Most of the wood that these guys are currently producing ends up as mulch. Various grades of mulch, and there's a lot of different grades. But anyhow, I've spoken with all of them, and all of them would be very interested in servicing a local fuel market. When discussing opportunities for fuel with each one of these different types of suppliers, it's really important to understand their side of the negotiation equation. In other words, why are they interested? What is motivating them to want to talk to somebody about selling fuel, or their wood as fuel? So just going down this list real quick. So the arborists, their main driver, if you will, is they just want to get rid of that wood as fast as they can and as cheaply as they can. They're not very concerned at all about what kind of price they're going to get for their wood. They're not going to ignore it, but that's not their main thing. What they want to know is, okay, where are you located and how much of their work do they typically do within 10, 15, 20 miles of your location? And if they do a lot of work within that radius, they're going to be very, very interested in working with you. Natural wood waste recycling facility, same thing. They're in business, and they remain in business because they're deriving profit from the mulch market. But the mulch market goes through seasonal upswings and seasonal downswings, and it's dramatic. In the spring and the fall, these guys do pretty well. In the wintertime, nobody's buying mulch. And during the wintertime is when you want to use wood as fuel. So this is a natural marriage. The loggers are going to be interested in as much as they can see a steady, reliable market. And they're going to be very carefully looking at the bottom line. For a logger to add the equipment to make a good quality fuel chip, it's not going to be cheap for them, so they're going to want to know that they can make their money back. And the primary indicative variable of that is going to be the cost of diesel fuel. So in other words, the cheaper their fuel of manufacture is going to be, the more margin that they will have. And as a consequence, the cheaper your fuel will be. And of course that goes in reverse. When the price of diesel fuel goes up, the loggers are going to want to have more money so that they can meet their costs. But at the same time, I think you're going to find that loggers are going to be very, very interested in being a supplier, because just like everybody else in business, they really want to diversify their market. So they're going to be an eager and willing audience. Sawmill basically apply the same dynamic as the logger, except the competition from the paper industry is what is going to be the primary driver of the fuel price. Aggregators are just constantly looking for new markets. The primary driver, if you will, for the aggregator is they're going to be offering you wood as fuel. You're going to price that fuel in terms of dollars per BTU, and they're just going to compare that price to what their markets for the various grades of mulch are, and they'll go with where they find the most opportunity to succeed. Now keep in mind that everybody in the wood business, with the exception of arborists, are all placing the greatest value on a long-term relationship. So price swings aren't that big of a deal. It's not like they're going to go unnoticed, but everybody in this industry is willing, they're very accustomed to selling one product at a loss for a while, knowing that that either allows them to engage or access other markets, or they know that one day that market will come back around and they'll make money again. As far as total volume, these are just some numbers I put together many years ago. The interesting thing about wood is the supply, the volume produced is very stable over time. If you think about it, especially within the arborist community and the wood waste recycling community, trees die all the time. Trees get hit by lightning. They get blown over in storms. Insects are constantly eating them. For whatever reason, there is always a need to maintain a tree, remove a tree. There's no link between a strong economy and a poor economy to the volume of wood that is being manufactured or produced by arborists and wood recycling facilities. Logging is very much dependent on the economy. During strong economies, we log more timber. During weak economies, we log less. However, the fluctuations really aren't that terribly difficult. When, just as an example, when the economy was booming back in the 90s and early 2000s, we were harvesting about 12,000 acres a year annually across all of Maryland. And today, the economy's not, well, during the low spot in the economy, we were still harvesting 9,000 acres a year. So that's not that much. I mean, it's a third reduction, but between 12,000 acres and 9,000 acres, there's only a loss of 3,000 acres across the entire state. That's not that much. Sawmills, they have very rigid production. You're not going to see this number fluctuate much at all. Aggregators, likewise. So anyhow, if you add it all up, we have plenty of wood to go around for everybody. 65 schools, 10 CHPs, figure your hospital's probably going to go with the CHP plant. It's a lot of wood. There's a lot of benefit to be had. This slide, all I want to point out with this slide is, so this line is oil prices. So carrying this out, notice that the chart stops at 2007. If we carried it out today, you would naturally see this curve having dropped, but that's fine. Just like Paul said, it's going to go back up. The interesting thing is, look at wood. And I can back this up for anybody that might be skeptical. Wood's very flat. So if you're trying to plan your budget for 5 years from now, you know what you're going to have with wood. You really don't know what you're going to have with oil. So in conclusion, wood's abundant. It's everywhere. It grows back. And the people that are candidates to be your supplier, they're already producing this wood. They're just not using it as fuel. But they're already making it. It's just going somewhere else. And anybody that would express an interest in buying this wood, you're not going to have any problems at all finding the suppliers, much less finding the supply. So with that, I'll stop and allow time for the next presenter.
Okay, thanks, Dan. We'll turn things over to Chris Clark here. He's got a few things to talk about with the Energy Grant Program itself, some details that you need to know about if you're considering applying.
Yeah, well, thanks a lot. Hope everybody can hear me.
Oh, yeah, go ahead, Chris.
Great.
We can hear you.
Thanks a lot. Listen, I want to say hello and thank you to the presenters for the introduction, and obviously, as you can see on the screen, my name is Chris Clark, and I'm the Clean Energy Program Manager for the Maryland Energy Administration. One of the programs that I administer is, as you can see on the screen, is the Biomass program. Increasing the amount of renewable energy is one of the state's key policies, and the Energy Administration is tasked with achieving the State Renewable Portfolio Standards, the RPS, and that's tasked with achieving the 20% energy sold in Maryland in 2022 coming from qualified renewable energy sources, with 2% coming from qualified solar renewers. And that's a carve-out but does not affect anything that has to do with biomass resources. But as of July 1, 2012, MEA recalculated the clean energy grant incentives based on several factors, including available funds, economy of scale, the desire of more equitable distribution of funds, and the cost of clean energy technology, capacity factors, potential annual production, and the data analysis from past clean energy awards. That's when our residential heating program was launched. In 2016, we've launched several new efforts under the clean energy grant programs. The MEA is excited to announce the opening of its first commercial wood energy grant program. This is something way and above, something that's been involved before. But the aim is create a kind of a launching pad for businesses to get into the game of moving away from traditional fuels and either co-fire or replace their existing heating units with what we assume will be primarily pellet-fired or wood-fired systems. So the grant process is open now and will close on March 30th, and I'll get into a little bit more detail on that in just a few slides. So because wood energy conservation systems have the potential to lower fossil fuel and electric bills while burning renewable, locally sourced, low-emission wood fuels, MEA intends to provide wood energy feasibility studies at good facilities in Maryland, and we'll get into those in just a couple minutes. But the upfront cost of the feasibility studies are often cited as a barrier to project development, and that's been something that's come back and forth to MEA and Maryland Department of the Environment and a lot of organizations, but by removing this barrier, what we want to do is give facility owners that will have the information necessary to determine the technical and feasibility of converting an existing fuel oil, propane, electric, and heating system to a wood energy conversion system, like the residential cleaning burning wood stove program. The WE program is open to properties that lacks mostly to natural gas. So the program is open to businesses, government agencies, nonprofits, including everyone that you see below. But these are some great examples of folks that would be great examples. So as stated before, the grant for each project will consist of a maximum of $15,000. The applicant is responsible for a cost share of $15,000 or 25%, I'm sorry. So we have a cap of $150,000 on this program. So it could conceivably be 10 programs that have $15,000, or programs that consist of less than that and have a considerable cost share. So applications will be completed accordingly, and it's not a first come first serve. They are all considered on a competitive basis. So you can go to the following our website address, and I'll leave that up for a little bit so you can write it down, and I will also put it up at the end of the presentation. So who, what, where, when? How will we evaluate these applications? It's always a tough budge, but you know what we have to do is the extent of every application will not be first come first serve, and we look at the proposed feasibility study. So this is the minimum that we need from each project, and I'm not going to read them through, since you'll be able to replay them. So, but the engineering proposal, the feasibility study, and all of our MEA requirements are listed on our website, which I'll give you in due turn. Now, this is a death by PowerPoint. The likelihood that a future project will result in a study has several different categories, and it would be great if you could go on to our study again to just make sure that your project is matching up to what we're looking for. So category 3 is just diversity of awards. So if you're if we get 4 hospital awards and 1 manufacturing award, it may tilt it one way or the other. Please make sure that you know, within your application you're looking for a significant manufacturing or use for your project. So from here, we've been very, very successful, and we also want to move to the commercial scale. So anything you can do to provide us with that would be great. And this is all my contact information. I'm going to leave this up for a couple minutes, so anyone that wants to write it down.
Okay, thanks, Chris. We appreciate everybody's contributions today, and we'll be sharing everyone's contact information when we post this on the website, and make sure that you have access to contacts so everybody knows how to get in touch with our presenters. And since we're running a bit long today, I want to encourage anyone, if you have questions, to contact any of the people or just contact me and I'll move things on to the appropriate people. So let's go ahead and wrap things up. I want to thank everyone for joining us and staying with us today. Once again, if you didn't register on the Eventbrite side to join us today, please send us your email. Send it to Jonathan at jkays@umd.edu, jkays@umd.edu, and we'll get this recording posted up to YouTube and to our website. We'll also be sending out an evaluation to people who've registered. And I want to thank everyone for joining us today. On behalf of Jonathan Kays, Paul Lewandowski of AFS Energy Systems, Dan Ryder from the Maryland DNR, and Chris Clark from the Maryland Energy Administration, this is Andrew Kling from the University of Maryland Extension saying thank you and have a great day.